Hi everyone, I'm Rachel.
And I'm Jenny.
And we're part of the Science Methods 2 team. So today we're making a video for you about shadows and sunlight and how it changes throughout the year. This is something we talk about a lot in class with Ted, but it can be kind of difficult to visualize until you see it with a globe. So we wanted to recreate the Shadows Lab for you here today so that when you're studying and trying to learn the information, hopefully it can be a little bit easier.
The reason this lab is so important is because the Earth is tilted on its axis, which gives us our seasons, and this lab can help us figure out how those seasons work. So for example, we have our Earth in its current orbit with the Sun, and the southern hemisphere is currently tilted more towards the Sun and receiving more direct sunlight and heat from the Sun, so it's experiencing its summer season, while at the same time the northern hemisphere is tilted away from the Sun and receiving more indirect sunlight and less heat from the Sun, so it's experiencing its winter season.
In order to understand shadows and sunlight and how all of this works, we need to know that there are 3 imaginary lines of latitude on the globe. The first line is the equator, which is represented here by the silver tape, and the equator runs at 0 degrees latitude around the entire Earth. The equator splits the northern and the southern hemispheres directly in half. The second line to know about is the Tropic of Cancer, represented by this piece of tape, and it runs directly along the Earth at this line of latitude. The Tropic of Cancer is important because it's the northernmost line where the sun can be directly overhead. This occurs on the summer solstice for the northern hemisphere, which is in June every year, so it's the day that the northern hemisphere receives the longest amount of sunlight. Conversely, we have the Tropic of Capricorn in the southern hemisphere, which is represented by this point of tape and also runs all along the Earth. This is the southernmost point where the sun can be directly overhead. This happens opposite of the summer solstice in the northern hemisphere. So instead of in June, it occurs in December. And this is the day that the southern hemisphere really receives the longest amount of sunlight.
As you can see, the little paper man is standing in South America on the Tropic of Capricorn. It is the summer solstice for the southern hemisphere, which means Earth is tilted so the sun is directly overhead of the tropic line and is the longest day of the year. As you can also see, the northern hemisphere is receiving indirect sunlight at this time, meaning that it has the opposite season and it is winter right now. On a quiz, you might see a question like this. It is the summer solstice in the southern hemisphere, and you are standing on the Tropic of Capricorn. It is noon, so the sun is directly above you. Which direction does your shadow point? As you can see, you do not have a shadow because the sun is directly overhead.
Another way you can visualize this and practice on your own is by making a 2-dimensional globe on paper. In this situation, the little paper man is standing in Iowa above the Tropic of Cancer. On a quiz, you might see a question like this. If you are in Iowa, what will happen to the length of your shadow as we approach the spring equinox? To figure this out, remember that the sun is shining directly over the equator on the spring equinox, and therefore both hemispheres receive equal amounts of sunlight. If we are approaching this day, the spring equinox, that means it is currently winter. The sun is in the same place as the last example using the globe. It is shining directly overhead of the Tropic of Capricorn. Since the northern hemisphere is receiving indirect sunlight, we can see that the little paper man standing in Iowa has a long shadow, and his shadow is pointing north. As we get closer to the spring equinox, Earth orbits around the sun so that the sun is shining directly on the equator. As we can see, the little paper man's shadow gets shorter. So to answer the question, if you are in Iowa, the length of your shadow will get shorter as we approach the spring equinox.